Okay, welcome back. So today we will discuss about another NLP application, which is stemming. If you remember, we said morphology is concerned about studying the structure of a word or the form of a word. And in that, we have said that words are made up of parts, and those parts can be free or bound morpheme, where the free morpheme would have a lexical meaning or a dictionary meaning, whereas the bound morphemes are morphemes or substrings that are going to be attached to the lexical term that are going to be attached to the lexical term to contribute different grammatical feature to the word. Okay. So one of the NLP process that we have is stemming, and the idea that we have, or the objective of any stemmer, is to reduce a term or any word, mind you, reducing a term or any word to their base form or to their stem. Okay. So as we said, a word might, have multiple prefix and suffix attached to it to show different grammatical features. And removing or stripping off those attachments and arrive at the stem is what we call stemming, and it's mostly used in information retrieval. So stemming, we say it's a crude chopping of affixes. As you can see, we are going to chop off or remove affixes, which means either a prefix, a suffix, or a circumfix. It can be any of this. But the process of stemming, again, we say it is language dependent, because the morphemes to be attached to the word, it depends on the kind of language that we have. So it's a language dependent task. So for example, if you have the word automates, so all of them would, or automatic or automation, all of them would reduce to the form automat, which means we are trying to remove whatever being, attached to it. So if you see, for example, if you see this input, it says it's a text. For example, compressed and compression are both accepted as equivalent to compressed. So if you simply pick the list of words, as you can see, each of these words appear only once. And for the computer, we know that compressed and compression are different because of, if you do a string comparison, all of them are independent words. But if you do stemming, we know that some of them would come to the same stem. So removing ed, removing ion is going to result into a word compress. So as you can see now, the word compress appeared 3 times after stemming. So the process of stemming is to remove the prefix and the suffix from a word and arrive at a stem. There is also another version of, or another variant of stemming, and we call it lemmatization. Now, to make it clear, when it is about stemming, the remaining part, or the stem, should not be a dictionary term or should not be found in a vocabulary. Okay, it's okay if it is not part of the vocabulary, but if it is lemmatization, then the remaining part, after you remove all the prefix and the suffix, the remaining part should be part of the dictionary. This is a requirement. So the goal of both stemming and lemmatization is to remove the affixes. Okay, that's the objective for both. But when it comes to lemmatization, the remaining part, which is a stem, which is going to be left at the end, should be part of the vocabulary. And that part, we call it a lemma, which means you have to check that the remaining part is part of the dictionary. Okay, if you do that, the process is called lemmatization. And the remaining part, which is found in a dictionary, we call it a lemma. But if it is a stemming, we don't care if the remaining part is part of a dictionary or not. That's the main difference between lemmatization and stemming. So as we said, a word, as I have said earlier, a word can be viewed as consisting of a stem and one or more affixes. So if you have words like, Amharic, if you have words like al-sabberkum, if you have words like al-sabberkum, we know that al is a suffix, sabbar is the main word, then ku is the subject marker, and me is the negative marker. So we know that a word is composed of a stem. In this case, it would be sabbar, and one or more affixes. So as you can see, we have the prefix al, and we have 2 suffixes, which is ku and me. Now, in stemming, in Amharic, if you have to do stemming, then this should result into sabbar. after removing al, ku, and me, it should arrive at saber. And if this word is part of the dictionary, we call it a lemma. If it is not part of a dictionary, then it is simply a stemming. So as we said earlier, a morphological analysis in its general form involves recovering, you see, we are concerned with recovering the lemma of a word, which means the part which is going to be part of the dictionary after removing all the affixes. And we know that the affixes are playing a grammatical property. In here, for example, al and me together are marking a negative, and ku is referring to the subject, right? It is referring to the subject that the person who is performing this action is first person singular መሆኑን ያሳየናል ማለት ነው. So in a stemming, it is a simplified form of morphological analysis, and what it does is simply identify the stem, remove the prefix and the suffix, whereas lemmatization, after removes it, then whatever is going to be found should be part of the dictionary or a lexical term. This is the only difference between the two. So these are some of the examples. You should be able to try it out by yourself using Python. But for that, you have to make sure that you have NLTK installed. I hope since I have already sent you the guide, along with the lecture notes earlier in this course, I believe all of you have installed NLTK. If you don't, or if you have any difficulty, when we meet tomorrow, we are going to see how to troubleshoot the installation of NLTK and how to update the NLTK package that you have on your computer. So for instance, from NLTK using regular expression, it's a stemmer. Mind you, stemmer, the whole objective, as we said earlier, is to chop off prefixes and suffixes. So the stemmer is a regular expression stemmer, and as you can see, it's going to remove the suffixes och or wuoch. And this is one type of plural marker in Amharic. So if you give it such kind of an input, then whenever it finds wuoch, you see, or whenever it finds och, wherever in the text, then it's going to get rid of it. So as you can see, ይሄ ለምሳሌ ቤቶች ማለት ነው። ብኤ ስንል ፎኖታይዝ አድርገ ነው ማለት ነው። Instead of ቤ ብሎ ከመጻፍ ብኤ ብለን ስንጽፍ, just like you do it in a Latin script, ብኤ means ቤ ነው አይደለም? ት as it is ት ነው፣ ቶ ነው። Okay? Then ች ራሱን ችሎ ች ነው። So this means ቤቶች ማለት ነው። So if you remove och, ምን ይሆናል ማለት ነው? You are going to be left with ቤት. ብኤት ማለት ቤት ይሆናል ማለት ነው። Instead of using the Latin script, we can use the Ethiopic script to phonetize our words ማለት ነው. But the problem in here is, as you can see, it looks for these substrings anywhere. ለዛ ነው መሃል ላይ የሚያገኘው. But since it's a suffix, it has to look for it at the end always. ስለዚህ you can add the $sign at the end of the substring. And as you can see, in this case, it removes only wuochen ብቻ ነው remove ያደረገው, ochen remove አላደረገው, because this is considered to be one string. በአንድ quotation ስለሰጠ ነው, it's going to be considered as one string. So for this purpose, what we have to do is tokenize it as a word. Tokenize ማለት እዚህ ላችሁ እንደሆነ, we talked about tokenization, right? What's tokenization, Mabrit? What did we say about tokenization? What did we say about tokenization?
Separate one from the other.
In a sentence, separate or identify each words ማለት ነው. So whenever you tokenize this one, ምን ይሆናል ማለት ነው? Tokenize ስናደርገው ቤቶች አንድ ይሆናል፣ እንአ አንድ ይሆናል፣ መኪኖች የሚለው ደግሞ አንድ ይሆናል ማለት ነው. That's what it does. So from these tokens, as you can see, የእያንዳንዱን word, these are the tokens. So we have 1, 2, 3 tokens. For each of them, we are going to do the stemming. And the stemmer is the one that we have in here ማለት ነው. This is a stemmer that we have. And as you can see, what it does is, at the end of the string, since we add a $sign, don't forget, a $sign always looks for it at the end, whereas a caret looks for it at the start. ቅድም የሞከርሽው ማለት ነው መብሬት. So what it does is, in this word, it looks for och at the end. ochን ስላገኘው ይቆርጥና ቤትን ይዛል። እዚህ ላይ there is nothing. የመጨረሻው ላይ ውኦችን remove ያደርጋል ማለት ነው. So if you want to expand your regular expression, then you can expand it in such a way. As you can see here, the one which is written in green, this is going to look for it at the start because we have a caret. ሌሎቹ በሙሉ ግን $sign ስላላቸው, it looks for it at the end ማለት ነው. So on a single word, it looks for እንደ የሚለውን መጀመሪያ ያያል። ክኡ፣ ክሽ፣ አ፣ አች፣ ን፣ አችሁ እና ኡ የሚለውን ደግሞ it looks for it at the end of the string. And whenever it finds those, it's going to get rid of them or it's going to remove them ማለት ነው። So mind you, the whole idea is stemming is about removing prefixes and suffixes from a word. But whenever you do that, since if you do it using regular expression, then it's a rule-based system. And in a rule-based system, you have to know, exhaustively the patterns. So you have to know what are the prefixes, you have to know what are the suffixes for this. So most of the time, what we do is we use an algorithmic approach. And in an algorithmic approach, as I said, if you use a rule crafting, it's very powerful, but we know that you have to be exhaustive. You have to exhaustively list all the rules. So the other thing, the one example that we have for the English language, by the way, the English language is the simplest language for morphological analysis or for any NLP application. We have a Porter-Stemmer, and it uses a very simple algorithm to determine, which part of the affix should be removed or not. So for instance, yes, yes. Any question? Any question? Okay. Okay. So for example, if you give it the word hopped, then we know that ed is a past tense marker, so it's going to remove it, but it will remain as HOP. Then it has a repair process. Repair ያደርገዋል ራሱ. So repair ሲያደርገው, then it's going to say hop. Just a moment. So in this algorithmic approach, as you can see, if the word that's given as an input is hopped, we know that ed is a past tense marker, but whenever you remove it, it will remain as HOP. So this is stripping off or removing the affix. But whenever you do that, it's common to see that you might remove the part which should not be removed. So in a rule-based approach, we also have what we call a repair action. So the repair action is whenever you have such kind of a pattern, then add E if the word is short, you see? After removing ED, if the word is too short, then add E to it. And how did the person came up with this rule? He came up with this rule by studying all the English words. There is no any mathematical algorithm to arrive at such kind of a case, because language is a natural phenomena, or it has a huge cognitive process. Then you have to understand that cognitive process to do the morphological analysis. What if you have such kind of a word, hopped? Then again, in this case, whenever you remove ED, then you are going to arrive at HOPP. So in this case, if you have double P's at the end, then remove it. Because for the first case, these are two different words. The first one, hope, means your desire for the future, your wish ማለት ነው. The second one, hope, means to jump on something, or የሆነ ነገር ላይ መሄድ ማለት ነው. መሳፈርም ሊሆን ይችላል, or መግባትም ሊሆን ይችላል. So we know that in such a case, whenever you have double P's, then you have to remove these two. Otherwise, for both words, if you simply remove ED, the first one is going to be HOPP, which is not a valid word, and the second one is hope, which means to jump on something. But actually, the base word is in here is a wish ማለት ነው. HOPE ነው refer የሚያደርገው. So to do such kind of things, you have to really understand the language. So the algorithm that we have in here is, it's easy to understand and easy to implement, but the disadvantage is you have to get all the rules and exceptions. Okay? Since it's a rule-based system, you have to know all the rules and exceptions, otherwise your algorithm is not going to work really well. So I'm going to go through Porter-Stemmer very briefly. If you want to, you can go and see it. But this is just to show you how a rule-based stemmer is going to be developed, even for the English language ማለት ነው. So as I said, this is not for you to show you how each and every step of a Porter-Stemmer works, but I'll try to explain the basic things in here. So it's a simple, remind you, it was developed in 1980s, and it's a simple rule-based algorithm for stemming, and it uses heuristic method, which means it uses a knowledge base. It depends on the knowledge that you have, and it is a collection of, a collection of ifs and rules, which means if a string ends with ATIONAL, then substitute it with ATE. የሚል አይነት rule ነው የሚቀመጠው. So what it does is, it looks into either the start or the end of a string. And if that satisfies a condition, then it would do some kind of string substitution. So let's say የሆነ condition ሲሟላ ATIONAL substitute it with ATE ይላል ማለት ነው. So if you find words like a relational, as you can see, it ends with ATIONAL ይላል. ይሄንን በማቀየረው it changes with ATE. ስለዚህ ምን ሆነ? A relational will change into a relate. So it is a collection of such kind of rules. We'll try to see some of them very shortly. So the algorithm consists of 7 sets of rules. And in each of these, there are multiple steps. 7 rules in Oronji. In each of them, there are many steps. And mind you, in a rule-based system, the order of execution is very important, which means the way you execute the order, the way you execute the rules are very important, like rule 1, then rule 2, then rule 3. Then within rule 1, step 2, you cannot jump from one to the other. So in a rule-based system, order of execution is very crucial, or it's very important for its success. So there are some definitions in Porter's Stemmer. The definition is it defines, or he defines, what a consonant means or a vowel means. And as you can see, for Porter's Stemmer, mind you, it's not a linguistic definition. For the Stemmer, for this computational process, consonant means anything except A, E, I, O, U, and Y. You see, usually we say non-consonants in English are A, E, I, O, U. But for morphological purpose, for a stemming purpose, Porter also considered Y to be part of a vowel. That's, consonant any letter other than except this mallet, no? And vowels are these letters nacho. Vowel mallet A, E, I, O, U, including Y. Mind you, this is not a linguistic definition. This is a definition by Porter for the purpose of stemming. And he defined a word in such a form. Mind you, as we said earlier, in computational linguistics, the most important thing is how you represent your knowledge. And for Porter, English words are represented in such a way. English words are represented as consonant, a collection of vowel consonant, M number of times, then a vowel. በዚህ መልክ ነው define ያደርገው. So C is a string of 1 or more consonants, and V is a string of 1 or more vowels. So what we call a word is a consonant followed by a vowel consonant M number of times. M is the number of times a vowel consonant appears, then another vowel. This is how he defined. Mind you, as I said, this is not a linguistic definition, mind you. It's not a linguistic definition. It is a definition that's made by Porter for the purpose of doing a stemming. So these are the formats of the rule that Porter came up with. If a condition is satisfied, okay, see, this is what it says. If some condition is satisfied, substitute S1 with S2. Okay, that's what it says. If a condition is satisfied, substitute S1 with S2. Now the question is, what are these conditions? Okay, the string substitution is very simple, but what are the conditions? And those conditions or parameters will be defined, later on. Some of the parameters are this. As I said earlier, M means the number of vowel consonant patterns that you have. Okay, you want to text ቢሰጣችሁ ለምሳሌ, what is M in here? Steve, who can tell me? What is M in the word satisfied? Yeshuas? Yeshuas? Yeshuas?
Yes, yes.
In the word satisfied, what is the value of M?
Count the number of letters.
Yes, tell me the number.
1, 2, 3, 4, 5, 6, 7, 8, 9. 9.
ለምን M ምንድን ነው የሚለው እዚህ ጋር?
Number of VC pattern.
What are the VC power? What are the VC patterns? How many VC patterns do you have? Yeah?
3.
Exactly 3. 80,
80. IS.
IS እና
ED.
ED አይደለ? vowel consonant ከተከታተለበት እነዚህ ናቸው። So for this case, M is going to be 3 ይሆናል ማለት ነው። That's what it means. Okay? And the other parameter is asterisk S. It means the stem ends with S ማለት ነው። ለምሳሌ እንዲህ ላረግ እችላለሁ። እንደዚህ ብዬ ላስቀምጥ እችላለሁ። Sorry. Let's say እንደዚህ አልኩ ማለት ነው። The stem that ends with ED ማለት ነው። በED የሚጨርስ ማለት ነው። This is the second one. This one means the stem contains a vowel. Okay? This one means the stem ends with a double consonant. ለምሳሌ መጨረሻ ላይ እንደዚህ ብዬ ብጽፍ ማለት ነው። If you have the words like boss, ይሄኛው አሁን it is true because as you can see it ends with double S. The last one, asterisk O, it means the stem ends with consonant vowel consonant pattern. መጨረሻ ላይ consonant vowel consonant ያለው መሆን አለበት ማለት ነው። consonant vowel consonant መሆን አለበት መጨረሻው ላይ። Okay? consonant vowel consonant ከሆነ በኋላ ግን ምን ይላል? The second consonant, the second C cannot be W, X, or Y. Mind you, to come up with this rule, you have to know all the words in the language. ለዛ ነው ቅድም እንደዚህ ብለን አስቀምጠናል. Don't forget. In here, the power is, it's very powerful, but the disadvantage is it's hard to get all the rules and it's hard to get all the exceptions. Okay? Okay? Clear now? Is it clear? Is it clear?
Yes.
Okay, you have to respond. Okay. So, this is what it says. You see, it has all these parameters. It has a condition. It has a definition for what a word is. Now, let's see some of the rules. For example, this is, I'm going to take only some of the rules. For example, the first step is concerned about, removing plural markers. And what it says is, in the first step, it says, if the word ends with SSES, change it with SS ነው የሚለው። So ለምሳሌ cares የሚል ሲያገኝ cares with double S ይሰጠናል። IES, if the word ends with IES, change it with I. If the word ends with SS, just put it as SS. And if the word ends with a single S, then remove S ነው የሚለን ማለት ነው። So this is the first step. Mind you, a step is very important, or the order of execution is very important. Then if you go to step 2, the first option, 2A, as you can see, it is concerned about past tense and progressive form. Mind you, each of the rules, each of the steps are designed to tackle one type of morphological change on the word. So it is designed for past tense and progressive. And what it says is, mind you, have a look at this one. If M is greater than 1, what is M? M is the number of vowel consonant sequence ማለት ነው አይደለም? If it is greater than 1 and if it ends with EED, change it with EE ነው የሚለው። ስለዚህ እዚህ ጋር ስንመጣ ምን ይሆናል? As you can see, M is greater than 1, the vowel consonant. ቀጥሎ ምን ያደርጋል? EED, it will change it with EE. So agreed will be agreed. ኮንዲሽኑ የማይሰራበት ኬዝ ለምሳሌ እዚህ ላይ ኢኢዲን ሪሙቭ ስታረጉ ኦርም ባታረጉት ራሱ ምን አለ? How many vowel consonants do you have in here? How many vowel consonants do you have? Only one, አይደለ? But the rule says it has to be greater than 1. So in this case, you don't make any change. You make a change only if the rule is satisfied. So what we are going to do in here is, as I have told you, first what it does is it checks the condition, and if the condition is satisfied, then the substitution would be made. Just a moment. So as you can see, whenever the condition is satisfied, like if the vowel consonant is greater than 1, and if it ends with EED, then it will substitute it with EE. So these are, some of the examples where the condition is correct and the condition is not satisfied. And this one says, if it is within a vowel or in the stem, if you have a vowel, and if it ends with EED, then ED, then remove ED. So for example, in this case, as you can see, after removing this one, after you remove ED, the remaining part has a vowel in it, አይደለ? So it means you are correct. But in here, after you remove ED, what's happening? In the remaining part, there is no vowel, but this one says, vowel መሃል ላይ መኖር አለበት ይላል. So in this case, don't do it ማለት ነው, because the condition is not satisfied. So this way, he came up with multiple rules. For instance, if you see step 2B, it says it's a cleanup. And these rules are going to be run if the second or the third rule in 2A are applied. You see? The second and the third rule of 2A, if they are applied, then 2B is going to be done as a cleanup. ምን ያደርጋል? በ80 ካለቀ then 80 ይለዋል። በBL ካለቀ then it will change it to BLE. And the other one, mind you, asterisk D ማለት ምን ማለት ነው? እዚህ ጋር ይሁት. If it ends with double consonant. If it ends with double consonant, and if that consonant is not L or S or Z, ከነዚህ ውጭ ከሆነ ማለት ነው. Mind you, this is a not sign. ከሆነ change it to single consonant ይላል. For example, the word was hopping. So ምን አደረገ? It remove ing. Then it remain with HOP. አያችሁት? HOP ሆነ. So double consonant ከሆነ remove one of the P's ይላል. If it is a double consonant, then make it a single consonant ይላል. If the word is tanned, then EDን remove ያደረግና since it is a double consonant NN, tan ብቻ ያደርገዋል. But mind you, if the double consonant is L, S, or Z, then you're not supposed to remove it. Have a look at this one. ለምሳሌ falling ሆነ ing remove አደረግ ነው አይደለ? You are left with two double L's. ነገር ግን L ከሆነ remove አታርጉት ስለሚል then it will remain as it is. So we have such kind of many rules that, like for example, step 3 and step 4 are trying to eliminate or change Y into I. Happy ላይ ወደ I ይቀይረዋል. Okay, sky ላይ ወደ sky ይቀይረዋል ማለት ነው. As long as it has a vowel within it, it's going to work on this one. Then another rule in step 4, there is a derivational morphology. If the number of vowel consonant is greater than 0, then Asianalen ወደ 8 ይቀይረዋል. If it is greater than 0, Izationን ወደ I's ይቀይረዋል. So if you have generalization, it would be generalized. If it has sensibility, then it will change it to sensible. So these are the combination of rules that he came up with for the English language. So if you want to develop a rule-based morphological analyzer or stemmer for Amharic, what is required is for you to understand each and every word formation patterns in the language. So as you can see, there are multiple steps. We have step 5, which is focused on derivational morphology. Step 6, which is the third type of derivational morphology. Mind you, since we say this is language specific, those rules for English doesn't work for Amharic. We know this. And the rules for Amharic doesn't work for Tigrinya or for any other language. That's why we say stemming is language specific. And we have step 7A, which is again a cleanup, and step 7B, which is again a cleanup. As you can see, if the vowel consonants is greater than 1, and if it ends with D and L, then change it to a single letter. ለምሳሌ control ከሆነ L ናጥፉ, roll ከሆነ ግን don't do it. ምክንያቱም as you can see, M greater than 1 ነው የሚለው እዚህ ጋር. The vowel consonant that we have is only 1. 2 ቢሆን ኖሮ then double L እናጠፋው ነበር. So these are some of the steps that we have, and these are some of the examples. For instance, if you have the word computers using Porter's stemmer, step 1, rule 4 ላይ computer ያደርገዋል ስን አጥፍቶ, step 6, rule 4 ላይ compute ያደርገዋል አርን አጥፍቶ ማለት ነው. So these are some of the examples that we have in Porter's stemmer. Mind you, we are not here to learn Porter's stemmer. This is just for you to see how rule-based stemming can be done using the knowledge of the language. Okay, but there are some problems that we can see. The problems or the errors that we have in stemming is we have overstemming. Overstemming means removing too much of it. Okay, too much, which means removing the part which is not a stem. An affix. For example, in the word news, it is a word. ግን ምን ይላል? ኤስን remove ያደርግና new ይለዋል, which is wrong. We call this overstemming. The other one is understemming. Understemming means not removing what should have been removed. So these are the common problems that we have in stemming that you have to give attention to. Then the challenge that we have for our local language, for Ethiopian language, is One is morphological richness. Ethiopian languages are known to be morphologically rich. They are very complex. The other challenge that we have is orthography or the spelling. The scripting method is different. The way they are written is not Latin, so it adds some additional challenge for the person who is developing the stammer. Again, the morphology, we have many inflection and merit derivation. For instance, from a single Amharic word, like from the word, let's say, from the word sabbara, Kamila word, okay? From the word sabbara, we can generate up to 1,000 other words. Sabbara, sabbarsh, sabbar, sabro, sababro, sabran, sabr, si, sabru, sai, sabru, sabroan. We can generate up to thousands of words. So it is morphologically complex. If you see it for English, you can come up with only few of inflections. In addition to that, we know that in morphologically rich language, we have exceptional words that cannot be governed by the normal rule. So these are some of the challenges that we have in here. Okay, forget about this one. It's about morphology. So these are some of the examples. Make sure to try them out. Okay, and እንድትሞክሯቸው from NLTK stemmer አመጣና the regular expression stemmer, then ing እንሰጠ ነው. So whenever you give it the word cooking, it will remove ing. And you can also try it for the Amharic script, as you can see in here, using the Amharic script. ኦች ከፈለጋችሁ በላቲንም እየጻፋችሁት, if you say OCCH to mean och, then ሰዎች ብትሰጡት ኦችን ያጠፋና it will say ሰው ማለት ነው. So these are some of the exercise that you should do before tomorrow. ነገ ስንገናኝ እነዚህን ኤክስፐሪመንት እናደርጋቸዋለን NLTK, okay? Make sure to attempt them. But this would be the end of chapter 2 or topic 2 morphology. Next time lecture የምንጀምረው chapter 3 እንዘለዋለን. Chapter 3 should be when I come to Hawassa. We'll meet there and do it. ነገር ግን we'll move to chapter 4. Okay, ወደ chapter 4 ሄደን semantics እናያለን ማለት ነው. Thank you very much for today's lecture. Okay? I'll see you tomorrow.
Okay.
Okay. እነዚህ ነገሮች ሞክሯቸው ሁሉ